Hi, I'm Travis Elliott, and welcome to my desktop. In this video, we're going to talk about the reactor configuration utility. If you have a reactor key fob controller, this is how you're going to load settings or configurations into your controller. As we said, there's absolutely no programming required, and this configuration utility is free to our reactor and key fob customers. So, when you first launch the configuration utility, here's the screen that you're going to be greeted with. First of all, it's going to pop up this little box and ask you for your COM port and your baud rate. Now before we get started here, you need to make sure that your controller is connected to your computer and also plugged in. The power supply must be connected to the controller. Now you can connect to the device through USB 802.15.4, ZB Zigbee Mesh, or XSC. These all essentially work the same because they create a virtual COM port on your desktop, whether that be the 802.15.4 modem or the actual little ZUSB module plugged into the board. They all create a virtual COM port after you install the FTDI driver. If you have not installed the FTDI driver, go to our website, go to the resources page. There will be a box that says drivers, and there will be a box that says USB driver. This is the driver that you're going to install for ZUSB modules, 802.15.4, XSC, or ZB Zigbee Mesh. Once you have the driver installed, a virtual COM port is going to appear in your device manager. So let's look at that now. In Windows 7, I go to my Start menu, I go to Control Panel, System and Securities, and then I go down here to, under System, I go to Device Manager. This will display my device manager. In Windows XP or other operating systems, you will need to find your device manager to find out which COM port it's assigned to. Here we can see ports and COM and LPT ports. You double click on that and it's going to show you all of them. You'll see I have one here that says USB serial port COM9. That is the port that my controller is attached to. It will show up as a USB to serial port. This is my virtual COM port. Like I said, mine happens to be 9. So now that I know what port I'm on, I can close these two windows and I can enter COM9. Now if you get a second little box here that says baud rate, don't worry about that because that's self-sensing. The controller and the configuration utility know what the baud rate needs to be, so it doesn't matter what this says, so don't even worry about that. You just need to select your COM port and click OK. Now once you do that, this little status box here is going to show you whether or not you're connected to your controller. Mine says connected to controller, but if there was an issue, it would say warning, not connected to controller. At that point you need to check to make sure that your COM port is correct, and if it is correct, make sure you have that FTDI driver installed. That is a must. So up here at the top of the page, we'll see some device information. The controller I have attached happens to be a Reactor Series controller. I have it connected through USB. It was developed in 2010, and I have a version 1 controller. So that's really all that does. Now down here you'll see some buttons. The first button says Load Configuration from File. You can save configurations to a file and then you can load them at any point. So if I were to get on controlanything.com and download a configuration that they used in an application, such as the automatic garage door opener configuration, what I did was I created a file on my desktop that says Reactor Configurations. Then anytime I configure a configuration that I want to save and I want to be able to reference to later, I can save it to that file, and then I can simply open that file and load the configuration at any time. So we'll go ahead and click on here, and you'll see that you can find where it's at. Mine's on the desktop, and it's in this Reactor Configuration file. So you'll see I have the automatic garage door closer here, and I also have my light plus button activated relay. I could click on the automatic garage door file and now that's going to load it in here and I can actually see what it does in these tabs. Of course we're not going to mess with that right now, and I could save it to my controller. But I don't want to do that, so we're just going to set controller to new condition. This is really handy if you want to erase everything out of the controller. It's going to go back to factory settings where all of these are blank. Okay. Now by doing that, I accidentally pushed the wrong button. My controller has 8 relays, and I'll see that this says relay 1. Well, I have more than one relay. The way that you change that is under this edit protected data. You just click on that right there. I don't recommend playing with this too much because you can change some things around and it's a real pain. So I'm going to set this back to 8 relays, and I'm going to say store protected data. Now that stored that data to my controller. However, it did not change it in my configuration utility. Maybe one of these days we'll do a revision and fix that. But for now, what we need to do is we actually need to close the configuration utility, and then we need to reopen it. Of course, yours isn't going to start up Visual Studios, but mine is, so go ahead and do that. I'm going to select my baud rate again, click OK, and now you'll see I'm connected to the controller, and if I click on output it says I have 8 relays. So if that ever happens, that's what you need to do. Go in here and edit that protected data, store it, close the configuration utility, and restart it. Okay. Otherwise, try not to mess with that too much if you don't have to. You can get yourself in trouble. So that's about all there is to do on this page. Once you have your configuration all set up, you can click Save Configuration to Controller, and that actually stores the configuration into the controller. So after that, you're really ready to test it. But let's move on to the next screen. I always recommend moving through this configuration utility in the order of the tabs. So I'm going to start on Input, and I'm going to go to Output, then Events if I need to, and then if I need to I can take Control. But let's start on this first tab. This is how you control what the inputs of your controller do. You'll remember in one of the videos we talked about inputs for a whole video. This is how you control what those inputs do, the actual inputs on your controller. I have my jumper set to the pull up position. There's a jumper on there that says up or down. Now if I move that jumper from up to down, you'll see all of the green bars went all the way down. That's because I put it in pull down position. But for the most part, I recommend leaving the controller in the pull up position. So let's go ahead and set that back to pull up position, and then we'll move on. So now I'm back to the pull up and all my bars go up. Okay. Now you can trigger the relays by an input directly. So I could say input 1 triggers a relay. I could also say input 1 triggers an event. I could do it if it exceeds a limit or input crosses a boundary. Let's take a look at how this works. This is where I say trigger a relay or trigger a event whenever input 1 is triggered. The next little window here is when it triggers that event or relay. I can say if it goes below a set limit, above a set limit, inside set limits, or outside set limits. If I say below a set limit, let me go ahead and show you what a contact closure looks like on input 1. I'm simply going to put a wire from the ground connection to AD input 1. And you'll see analog input 1 go from 255 all the way down to 0. That's just me putting a wire across that input, on and off. Okay, so you'll see it went all the way down to 0. So let's say we want input 1 to trigger a timer. We'll say if input exceeds limit, and then we'll say if it goes below a set limit, and you saw it went from 255 to 0, so I'm going to set this to 253. Okay, and I'm going to have it activate timer 1. You can have it activate a timer, cancel a timer, increase a rotation, decrease a rotation, trigger an auto rotation, or cancel rotations AB, ABCD, ABCD, and you can also have it select multiple events. If I were to select multiple events, watch the tabs at the top of the screen, you'll see that another one pops up, multi-event configuration. If I click that, I can have input 1 do a whole bunch of things. I can have it activate timers 1, 2, 3, and 4. I could have it cancel timers 5, 6, 7, and 8. And I could have it increase a rotation. You can have that one input do a whole bunch of things. You can have it trigger a whole bunch of different events at once. Trigger them, increase them, decrease them, cancel them, whatever you want to do. For now, we're just going to have input 1 activate timer 1. Okay, so you'll see whenever it goes below the set limit, which I have set to 253, it's going to activate timer 1. So if I trigger this input, you'll see that it went all the way down to 0, which definitely went below 253 and is definitely going to start timer 1. Okay, so now let's go to the next page. That's pretty much all there is here. One thing I do want to mention is on this page, if you're using a sensor and you want to know what point in the range you want it to trigger, you can trigger that sensor. Like with a heat sensor, you could use a lighter and a cup of ice, as we showed you in that little sensor video. And you could see where it reads on this scale. Whenever it gets to a certain point on the scale, you can have it trigger a relay or trigger an event. So that's how you figure out exactly where on the scale you want that analog input to trigger an event or relay. I won't go into that too much because you'll fall asleep on me and then this will be completely useless. So we're going to move on to the next tab, which is output. This is where you tell the relays what to do. You can have the relays triggered by an input directly. You'll see relay 1 is triggered by, it's controlled by input 1 directly. I want to activate relay 1 when timer 1 comes on. So I'll click this drop down menu and I'll say it's on while timer 1 is active. I could also say that it's off when timer 1 is active. There's all different ways that you can control the relay. Okay, so I'm just going to say is on while timer 1 is active. Okay, and that's basically all I need to do on this page, and relay 1 is going to come on when timer 1 comes on. As we saw here, timer 1 is going to come on when my input goes below 253, so whenever I generate a contact closure, timer 1 will start. All these other relays are controlled by input 1 directly. We're going to go ahead and change that. We'll change them so that they're all controlled by separate inputs. We could have multiple relays controlled by one input. You'll see here relay 5 and 6 are controlled by input 5 directly. And I could say that that input turns a relay on. I could also say that the relay is equal to the input state, so if the input is on or up to 255, the relay is going to come on, and if it goes down to 0, the relay is going to go off because it equals the input state, and 0 would be off, 255 would be on. I could also say not equal to state, so if it's 255, the relay is actually going to be off because the input's on, the relay is the opposite of the input state, which is off. So I'm going to say not equal to input state. Okay, since all of my relays or all of my inputs are pulled up, which means they're all up to 255, which means by default they're all on. I don't want my relays to be on right now, so I'm going to say not equal to input state, because you'll see back here all of the inputs are on 255, and I don't want all my relays to be on all the time. So to fix that, I just say the relays are controlled by the inputs directly and they're not equal to the input state. Okay. And that's about all there is to that. I'm going to go ahead and set these to be controlled by input 7 down here. So if I trigger input 7, relay 7 and 8 are going to come on. If I trigger relay input 5, relays 5 and 6 will come on, so on and so forth. And that's about all there is to that. Okay, so now we're done with the output configuration page. I hope I'm not moving too fast. If I am, you can rewind this video and watch a little bit more. But we're going to move on to the reactor event configuration page. You'll remember in the event video I told you that you have 8 timers. And here are your 8 timers. Timer 1, 2, 3, 4, 5, 6, 7, and 8. This is how you configure those timers. In this little setup, we're using timer 1. Okay, so let's configure timer 1. I can set it to come on for any amount of time I want. So when input 1 triggers timer 1, I can have it come on for as long as I want. I'm just going to set it to 5 seconds. You can set it for several hours, several minutes, several seconds, whatever you want to do. You'll also remember we talked about event piping, where an event triggers another event. This is how that works. We're on timer 1 here, and we see this little box here that says when finished, trigger function. I can have it trigger any other event I want right here, or cancel any other event I want. So I could have it activate timer 2, I could have it cancel timer 3, I could have it increase or decrease a rotation, I can trigger an auto rotation, I can cancel rotations, anything that I would like to do. But for now, we're not going to do event piping. I'm just going to say stop, do nothing. And that's really all there is to the timers. I have the relay tied to the timer's tied to the input. So essentially at this point we would pretty much be done. Okay. So now you'll see on down here we have our rotations. You have rotations A, B, C, and D, the 4 we talked about in the event configuration video. We have all different types of rotations here. We have binary, sequential, incremental, and reverse incremental. For now, we're not going to talk about what each one of those are. We may get into it later in the future, but I want to get this video out to you guys, and I don't want it to be 3 hours long. So I'm just going to tell you, if you want to, you can play with these rotations, and you can change a different type of rotation here. You can also change the count of the rotation. You'll remember we talked about counts and how you can change how many of them you want. So here's how you change the number of counts in the rotation. You can have it go from 0 to 1, you can just have it be 0, or you can have it go from 0 to 9. Okay, so any amount of counts that you want, you can change right there. You'll also remember we talked about how by default rotations recycle. So if it's a 9 count rotation and you increase it on the 9th count, it's going to go back to 0. However, I also told you can halt on upper and lower limits. This is where you change that. So you can tell it's a halt on upper and lower limits, and that's basically the way that you change that. Really pretty easy stuff. And then you can change the delay between counts right here. So you can have it sit on each count for a specific amount of time. Now as far as time is concerned, whenever we're talking about seconds with a timer or seconds with a rotation, that can be defined right here. You can define the length of a second. We found 363 to be very close, and this is actually the number of beats that the chip makes in 1 second. So it makes 363 beats, and that equals a second. If you don't think that that's quite right, because every resonator and every board is just a little bit different, you can fine-tune that. You can change this. You can say that second seems to be a bit too long. I'm going to change it to 200. Okay. Now, if you change that and you forget what we said a second was and you want to go back to that, you can just click this Restore Default, and it's going to go right back to 263. So that's how you change how long a second is to the reactor. Because what the reactor thinks is a second and what the rest of the world thinks is a second can be 2 different things. And that's how you fine-tune that, is right there. So that's about all there is to the event configuration screen, or at least that's all I'm going to get into for now. I think that that's going to give you a little head start, and you can really start playing with events if you'd like to. Everything to do with events can be done right here. Okay. Now on the next tab, we have override reactor logic. You'll remember I told you the reactor was designed to make decisions on its own. However, you can still take control of it at any time you want. So we could, all my relays happen to be on right now because they were all equal to input state, and you'll see if I can read my A to D inputs over here, you'll see that all of the inputs are on, which means all of the relays are on. So if I click get the status of relay 1, you're going to see that they're all on. Now, as I said, you can take control of the relays. I can turn the relays off right here. You can probably hear them clicking in the background. Now if I read them, they're all off. So that's how you take control of the relays at any time you like. Now, whenever I take control of the relays, that means I told the reactor to go take a coffee break. I'm going to take control of this relay. So the reactor does not have control of the relays right now. You and your computer do. Once you're done playing with the relays and doing what you want to do with them, you can tell the reactor, okay, take control. I can return just relay 1 to the reactor, I can return relay 1 and 2, or I can return them all at once by clicking this button. And that's going to return control of all relays to the reactor. You always need to remember to do that after you're done taking control of the device. You need to return control to the reactor chip. And that's how you do it. I can also set the status of all relays at once here by typing in a number. Each relay has a binary value. Relay 1 is 1, relay 2 is 2, relay 3 is 4, relay 4 is 8, 16, 32, 64, 128, and that's it. So if you add all of those numbers together, you actually get 255. So if I want to turn all the relays on at once, I would type in 255 and hit enter. And that would change the status of all relays at once. It would set all the status. If I just wanted to turn on relay 1 and 2, I could just type in 3, because 1 plus 2 is 3. And that's how you would do that. Okay. Now, down here you'll see another box that says select event to trigger. I can trigger an event manually. I could trigger timer 1 manually by clicking activate timer 1, and then I could click trigger reactor event right here. And that way I can trigger any event that I want to manually from my computer. So this screen really gives you full control of the reactor at any point. And this is how you take control of it from your computer very easily. That's just about all there is to this page. I don't think I want to get into anything else on this page right now. So now that we have all this set up, we have input 1 triggers the timer when it goes below 253. We know that relay 1 is going to be on while timer 1 is on. We know that timer 1 is a 5-second timer, so basically whenever I trigger that input, timer 1 is going to come on for 5 seconds and then go back off. Now that we have all that set up, we can just say load configuration or save configuration to controller. You'll see this little progress bar at the bottom, and my configuration has been stored to the controller. Now I always like to go to the input screen so I can see what's happening here. What I'm going to do is I'm going to trigger a contact closure on input 1 just by putting a wire across the 2 terminals. Whenever I do that, it's going to activate timer 1, and that's going to turn on relay 1. So I trigger analog input 1, which you'll see here activates timer 1. Timer 1 is going to activate relay 1 for 5 seconds and then go back off. So let's see it in action. And I know you can't see this, but listen, you'll hear the relay click whenever that input goes down. My timer's on and my relay's on. My timer just went off and my relay went off. And that is essentially all there is to configuring your device. Now that I have that configuration stored into my controller, I can disconnect it from my computer, and I can take it out and I can wire it up, and it's going to run through the configuration I told it to. So that's about all there is to configuration utility for now. So I'm going to leave you with that. I hope that you'll get one of these controllers and you'll experiment with it. I hope that you'll go into our application pages next and do a little application with us. That's going to help you learn how to use a controller. We're going to have a lot of applications, so be sure and check those pages out. And I really hope that this Reactor Logic series has been useful for you. I'm really glad that you sat through all of it. I hope you learned something, and I hope that you have a thorough understanding of how reactor and key fob controllers work now. So I'm going to leave you to it. If you have any questions, you can give us a call. We're open Monday through Friday, 9 a.m. to 4:30 p.m. Central Standard Time. Our number is 417-646-5644. Our website is controlanything.com. You can also reach me directly by email. My email is travis@controlanything.com. I'd be glad to hear any questions you have or any comments, or if you just want to talk about a little application you did, I'd love to hear about it. So I'll leave you guys to it. Go out there and have some fun, and I'll see you next time. Thank you.